For this screencast, we're going to look at solving systems of linear equations by graphing. There are many methods for solving systems of linear equations, and we're going to learn about several of them in Chapter 9. The first one we're going to take a look at is how to solve a system by graphing. A system of equations has two or more equations that are in the same variables, and here we can see we have two equations both involving x and y, so two equations and two variables. If we graph these equations, we can see if they have a common solution. In other words, is there a pair of numbers that I can substitute in for x and y here that will add to 1, and also when I substitute in here will result in 8. So where the graphs intersect, where the two lines in this case intersect, would be the solution to that system. So first we're going to actually change the equations here. I'm going to transform them so that we can have them in slope-intercept form. 2x minus y equals 8 becomes y equals 2x minus 8. In other words, I just subtracted 8 from both sides and added y to both sides of my equation. And x plus y equals 1 becomes y equals 1 minus x. So here I just subtracted x from both sides. So now I have a system of two equations, both in slope-intercept form, and we can graph these lines because we know the slope and the y-intercept. Here, the y-intercept is -8, so I'm going to put a point at -8 on the y-axis, and the slope, and remember we use the letter m to represent slope, not s, but m. M is the slope here, and that's change in y over change in x. So we're going to go up 2 and write 1 to get another point on this line, and up 2 and write 1. And we can continue with that pattern, and when we connect the points, we'll have our line. So here's the line y equals 2x minus 8, and now I'm going to graph the line y equals 1 minus x. So here our y-intercept is 1, and the letter we use to represent a y-intercept, remember, is b. So here b is 1, here b was -8. So I'm going to put a point on our y-intercept, and this time I'll use a different color. Let me use purple here. So our y-intercept is 1, and our slope is -1. So instead of the line going from the bottom left to the upper right, it's going to go from the top left to the bottom right. And the slope is 1, so that we can think of that as, or -1. Remember, this is understood to be a 1 in front of here. So we have -1 for our slope. I'm going to write that as -1 over 1. And this is our change in the y direction, this is our change in the x direction. So we're going to go down 1, right 1, down 1, right 1, down 1, right 1. And I think at this point you can probably see where the two lines intersect. The two lines intersect at point here. Let me change this to a different color so it doesn't quite blend in with the other line. So here we can see the two lines intersect at the point, let's see, 3, -2 is our solution to this system. X is 3, y is -2, and we can write that as an ordered pair since it is an actual point on the xy plane. Or if we wanted to, we could actually write x equals 3 and y equals 2. And one of the things I want to point out here is when we substitute in 3 for x, I think I might have said 2 for y, -2 for y, when we substitute these two numbers in to each of the original equations, it should make them true. So for example, if I substitute 3 in for x here and -2 for y here, 3 plus -2 is 1. And the same thing here. 2 times 3 would give me 6, minus -2, 6 minus -2 would be 8. So here the lines intersect. But will the lines always intersect? Let's take a look at another solution or another example. Here we have a system of equations that we're going to solve by graphing. And once again, to solve these, or to graph these, the easiest thing to do is to get y by itself and get the equations in slope-intercept form. So here I have the two lines already solved in slope-intercept form. The first equation, x minus 2y equals -6, when we solve it for y, becomes y equals 1/2 x plus 3. So in other words, I subtracted x from both sides and then divided by a -2. And the second equation, 2y minus x equals -2, when I solve for y by adding x to both sides and then dividing by 2, that equation becomes y equals 1/2 x minus 1. So let's graph these and see what happens. Our first line is y equals 1/2 x plus 3, so the y-intercept is 3. And the slope is 1/2, so I'm going to go up 1 and right 2, up 1 and right 2, up 1 and right 2, and so on. And I could go down by to the left here by going left 2 and down 1, left 2 and down 1, and so on. So this is our first line. Has a y-intercept of 3 and a slope of 1/2. And you may have noticed that our other line here also has a slope of 1/2. So let's see what happens when we graph that one. Its y-intercept is -1 and its slope is 1/2. So we're going to go up 1, right 2, up 1, right 2, up 1, right 2. And once again, I can also go left 2, down 1. So when we graph this line and connect the points, it looks like the lines don't cross. And that's true, the lines don't cross because the lines are parallel. And we could have figured out that they were parallel if we had looked at the slopes. As I mentioned earlier, it looks like the slopes here are both 1/2. And we learned in our previous chapter that if the slopes are the same for two lines, the lines will be parallel, which means they actually won't cross. So that means that there's actually no solution to this system of equations. And another way to write no solution is to write a 0 with a line through it. That's sometimes referred to as the null set or the empty set. And the way that symbol would look would be to draw a line, circle with a line through it. Alright, let's take a look at one last example. Here we're going to solve the system by graphing. And let's see what we've got here when we solve these for y. Oh, we don't actually have anything when we solve these for y. Let me see. This time I think I'm going to use the x and y intercepts. So when x is 0 here, y would have to be 2. And if y is 0, x would have to be 3. So do you remember the x and y intercept method? If x is 0, that gives us the y-intercept. And if y is 0, that gives us the x-intercept that we talked about in our previous chapter. So here's the one line. And let's do that same method with this second line. Let's pretend first of all that y is 0. So if y is 0, we'd have -6 times 0, which is 0. And then we'd have 0 equals 4x minus 12. We'd add 12 to both sides and then divide by 4. We would get x is 3 for the x-intercept. That's the same point we already had. Alright, well now let's pretend that x is 0. So if x is 0, I'd have -6y on the left still. But on the right, I'd have 4 times 0, which is 0. So I'm just going to have the -12, or -12. And then if I divide both sides of this equation by -6, I would get that y equals 2. But wait a minute, we already had y equals 2. So if I connect these points, I'd actually have the same line that I already had. Interesting. So that's a little different. What does that mean in terms of number of solutions? That means that this system of equations actually has an infinite number of solutions. That's the symbol for infinity. As long as the point is on this line, it will be a solution to this system of equations. And there's an infinite number of points on this line, so that's why there's an infinite number of solutions. So let's take a look at a summary here of our 3 examples. So for our 3 examples to solve these systems by graphing, there's 3 things that could happen. The lines could intersect, which means there's only one solution, one point of intersection. The lines could be parallel, in which case there is no solutions. The lines don't cross, so there's no numbers that work for both equations at the same time, or the lines could coincide. That's what we actually saw on the last example. They actually end up being the same line, which means there are an infinite number of solutions. And those solutions would be all the points that actually lie on the line. Don't forget to do the survey for your homework, and we'll continue to work with systems of equations on Thursday.